Welcome back to the Math Professors. This YouTube channel covers topics that can be found in any college math class, so if you consider liking, subscribing, and sharing, we'd appreciate you helping us grow our channel. So today what I'm going to cover is this antiderivative, and I want to show you that there's two different u-substitutions we can use, and you'll get the same answer back. So know that u-substitutions are not really unique. Sometimes there's more than one that works. So the first one people tend to pick is, well, let's go ahead and choose u as the secant of x, because I know the derivative of the secant of x is equal to the secant of x times the tangent of x. So if I pick my u to be equal to the secant of x, so that's going to be this piece here, then I know that my differential du is going to be equal to the secant of x times the tangent of x dx. Which is exactly what we have in the numerator. So this is the secant of x times tangent of x dx. So then I ask, students, what is still the original color out there? So we can see that we're still going to have, the division sign, the square root sign, and then we can kind of put in our colors, so our substitutions. So we know that the secant is going to be equal to u. And then we know that the secant of x tangent of x is going to be equal to du. It's going to be equal to du. I'm not a huge fan of writing du's in the numerators. It's fine. You see that in all sorts of books, but I prefer to actually write it this way. This is the integral of 1 over the square root of u du. I like to see my integrand as what we're taking the antiderivative of. So when I want to integrate this thing, I know this is the integral of u to the minus 1/2 du. So this is, add 1 to the power, divide by it. So this is u to the 1/2 divided by 1/2 plus c. So this is going to be equal to 2 times the square root. Let's put u back in pink. Times the square root of u plus c. And now what we have to do is we have to unsubstitute. So this is going to be 2 times the square root. Well, u is going to be equal to that secant of x plus c. Now, again, this was not really a unique way to substitute. So let's kind of put this back up here again. So I have the secant of x, tangent of x, all over the square root of the secant of x dx. So what I want to do is I'm going to try a different substitution. Let's just say the entire denominator is going to be my substitution, because sometimes, more than one will work, and it's interesting what it does. So if, u is equal to the square root of the secant of x, then I'm going to have to find my du. So it might help people to see this as the secant of x to the 1/2 power. So then when we find our du, our differential du is going to be equal to 1/2 times the secant of x to the negative 1/2 multiplied by the derivative of the secant of x, which is going to be equal to the secant of x times the tangent of x dx. And then, simplifying this expression right here is we're going to have du is equal to, crush these markers, du is equal to, we have the secant of x tangent of x all over 2 root secant of x dx. And what we notice in our new expression is, boy, this looks a heck of a lot like our our original piece here. So I don't really need the 2. My entire integrand is this thing without the 2, so I can say 2 du is equal to the secant of x tangent of x all over the square root of the secant of x dx, which really again is this entire expression right here is equal to this. So what I can say is that this thing becomes the integral of just 2 du. And the integral of that thing is going to be equal to 2u plus c. So our original u plus c. Now remember, u right here is now this expression. So this is going to be equal to 2 times the square root of the secant of x plus c. So I love it when there's more than one way to solve or evaluate a particular expression, and this is kind of clever that we get exactly the same thing back because we know that the general antiderivative is unique up to a constant. So again, thanks for watching, so please consider liking, subscribing, and sharing.